Scalars and vectors. Right, vector quantities have got both magnitude and direction. Magnitude just means size. That means vector quantities have got size and direction, and the size, the magnitude, is usually expressed as a number. So a good example of a vector quantity is force. Okay, so force, there may be a force of 6 newtons acting on a body, but it acts in a particular direction. So it might be pushing it up, or it might be down, or it left or right, or north, south, east, west, whatever. It's a force that's acting in a particular direction. And when you state a vector quantity, you actually have to state the size and the direction as well. And there's always marks for both in the exam. Now, scalar quantities are a bit different because they have got magnitude only, and a good example of one of those is mass. So you might say the mass of a body is 100 kilograms. Okay, that's how much matter is inside the body. There's no element there of direction whatsoever. It's all about size. Okay, so some examples of vector quantities are force, velocity, displacement, acceleration, and momentum. Examples of scalars are speed, distance, time, temperature, energy, and mass. We're going to talk about velocity and displacement and compare them to distance and time in the next slide. There's just one more thing I want to point out, which is acceleration does depend on velocity. So if you've got a quantity that depends on another quantity, and that quantity is a vector quantity, that means that the other one has to be as well. I've not made that very clear, but velocity is a vector quantity. Therefore, acceleration must also be a vector quantity. Same goes for momentum as well, of course, because that also depends on velocity. Now, this slide will help us see the difference between two quantities, speed and velocity. Now, speed was our scalar. Okay, so it has size only, and velocity is our vector. Okay, now they're both usually given the same magnitude. So if you're comparing a cyclist, you could say that he has a speed of 10 meters per second. You could also describe the velocity of that cyclist as 10 meters per second, because he's covering the same number of meters every second. The difference is that you have to give a direction if you're talking about his velocity. So you would need to say he is travelling at 10 meters per second north or 10 meters per second south. There needs to be some element of direction there. Now, the other one, which is quite interesting, is the distance versus displacement. Displacement is our vector and distance is our scalar. Now, if you imagine moving from a position A to a position B, they could be a couple of miles apart. You may travel from A to B along this really convoluted route. And if you do that, your distance travelled, how much ground have you covered during your motion, is going to be the length of that line there. And it could, for example, be 52 metres. I'm just making these numbers up, of course. Now, your displacement is slightly different because the displacement is the shortest distance between the 2 points. So your displacement would actually be significantly less, would also be measured in metres, but is the shortest distance between A and B. And that maybe in this case might be 35 metres, for example. So that's the difference between distance and displacement. Right, this is a quick gap fill to make sure that we've understood all of the terms, okay? Complete the following sentences using words from the box below. So we're looking for all our answers in the box. We can use the words once, more than once, or not at all. So we can't just randomly sort of, or not randomly, but use process of elimination with some of these. Okay, all measurements have a, now in brackets it's got size, so I know it's got to be magnitude. There's magnitude, I'm going to put that in magnitude because magnitude means size. Okay, something quantities only have magnitude. Well, we know that from our definition, and the answer there is scalar. Scalar quantities only have magnitude. Okay, then there's blank quantities have direction as well as magnitude. Well, I know that that's got to be vector quantities. Vector. Just noticed here that scalars, and we wanted scalar, not that it matters because you can use the words more than once. Okay, distance or displacement, question mark. Blank is a scalar quantity. Well, that sentence must be referring to these words before. So out of distance and displacement, which one is the scalar? And it's distance. So distance is a scalar quantity. When you walk to school, the distance you travel, perhaps, the blank you travel can be estimated by the number of steps you take. I think that probably is distance again. The distance you travel can be estimated by the number of steps you take. Then we've got something is a vector quantity. Now I'm assuming that's now we're going to talk about displacement based on this statement up here. So displacement is a vector quantity. When you arrive at school, your blank is the distance in a straight line from your home to school. Now that's the definition of displacement, the shortest distance in a straight line between where you started and where you end up. So that again is going to be displacement. Okay, next sentence then. You could work out this distance using a map, probably. Yeah, you could look on a map and look at how close, what the straight line is between the 2 points. Now the next sentences I think are going to be about speed and velocity. I'm going to change colour now because we've so they stand out. Speed and velocity, blank is a scalar, well that's going to be speed. Speed is a scalar and velocity is a vector. Velocity is a vector quantity. Even if you walk at the same speed during a journey, your velocity will change when the direction you are moving changes. So we might be going at 15 meters per second north, and then the road bends and we're going at 15 meters per second south. We're still at 15 meters per second, but the velocity has changed. Velocity, sorry, vectors or scalars is worked out, something is worked out using mass and velocity. Now I know that momentum is mass times velocity, okay, so momentum equals mass times velocity. You may not know that yet, so you would be struggling to get that right, but momentum is worked out using mass and velocity, and something is change in velocity. Well, I also know that acceleration is change in velocity, so I think that goes there. Acceleration is change in velocity, so they are both vectors, and they have to be vectors because they depend on velocity, which is already a vector. So if you've got a property that depends on a vector quantity, it will also be a vector quantity.